Good afternoon, everyone. Today we're going to do a video on volume, namely the volume of this composite object. And so what we have is a rectangular prism, the form of a box of sorts, with a cylinder cut out inside the center of the box. Okay, so we're going to take the volume of the rectangular prism and subtract away the volume that is made up of the cylinder in the center. You can imagine filling this box up with water, and maybe you can imagine like a rod going through the cylinder so that that space can't be occupied by the water we're going to fill the box up with, right? We're thinking of volume as capacity, right? The capacity to hold liquids, for example. And so that's one way to kind of visualize what we're calculating here, okay? So remember, the way we teach volume to our students is that the volume of a prism can be found by the area of the base times the length, or times the height, depending on how the object is oriented in space. And so for something like this looks like it's kind of laid out flat on the ground. So we can think about covering the base and then traveling through the prism and filling it up with water, okay? Or you can think of filling the bottom base and filling the water upwards through the height. And so either way, we're thinking of filling up the object with water, okay? And so the area of the base times the length for a rectangular prism is simply the length times the width. That would be the area of the base times the height. So we're going to have the area of the base times the length. So our volume in total is going to be the volume of the box minus the volume of the cylinder, right? Because we have to take away the volume that is taken away from the cylinder in the center, okay? It's cut out of the box. And so the volume of the box is going to be length times width times height for a rectangular prism. And then keeping in mind that the volume of a prism and a cylinder is, in some sense, a circular prism, right? It's simply a circle that keeps its shape the whole way through, that travels through some distance. And so it's like a base of a circle in the shape of a prism. And so that same general formula of the volume of a prism is equal to the area of its base times the length. I should add that as a subscript. Volume of a prism is equal to the area of the base times its length. Then, since the area of a circle is, I'll remind you, pi r squared, then the volume of that cylinder is going to be the area of its base, namely the area of the circle, which is pi r squared, times the length that it travels through. Right? Imagine filling it with water. We fill up the base, we cover the base circle, and we fill it up through the length of the prism. And so minus pi r squared times the length, so times the length, okay? And now, I like to write a general formula first with our dimensions laid out before we actually put in the values. And so now our job becomes that much easier. Our length is, let's say we'll make the length of our prism 12. Let's say we'll make the width 7. Write those down. Width is 7. The length is 12, so that the length correlates with the cylinder as well. And we'll have the height of 4. And so in that sense, we have a length of 12 times a width of 7 times a height of 4 minus pi times our cylinder is a cylinder with a base circle with a radius of 2. Radius is the distance from the center to the edge of the circle, and so our radius is 2. So our cylinder has an area of pi r squared for the base, so pi times 2 squared, and then times its length for its volume. And so now we can multiply the 3 dimensions for our box. And so the volume of our box is 12 times 7, that is 84. 84 times 4, and we'll take away pi times 2 squared is 4, so pi times 4, and I should put in the value of our length. Our length is 12, which we know, so times 12, and we can have that here as well. And now I think we're good to actually evaluate all of our calculations. So 84 times 4, that is 336, minus pi times 4 times 12. So pi times 4 is 12 pi times 4 is roughly 12.57. And so 12.57 times, that's 12. 167 times 12. That should give us around 150.84. Okay. And now to finish it off, we want the volume of the inside the box that is not inside the cylinder, so around the cylinder. And so we subtract the two, and we end up with a volume of 185.16 with our units of meters in every dimension. And so volume is a three-dimensional measure. We're calculating something that has 3 dimensions. And so our units are going to be cubic meters. And so our volume in the end is 185.16 cubic meters. Okay. I hope, again, like the surface area, I hope this provided a nice refresher. If it has been a little while since you studied volume, again, the volume of any prism can be found by the area of its base, imagining that we cover the base with some liquid, with water, and then times its length, so we fill up the 3D object through its length with water. And so we can imagine that the volume is its capacity to hold water. In that sense, it gives a nice visual of what we're actually calculating for problems like this. And so we get the volume of the box, we take away the volume of the cylinder that's cut out through the center. And so our total volume, that's total, I'm used to writing in French here, I apologize. Our total volume down here is 185.16 cubic meters. The power of 3, because we're measuring a 3-dimensional measure. So I hope this helps. If you have any questions, comments, suggestions, please let me know. And research videos are always appreciated, and thank you for watching.